We use a lot of chemicals in our water utilities. The Occupational Safety and Health Administration, better known as OSHA, tells us that exposure to hazardous chemicals is one of the most serious threats to workers today. And that threat is particularly relevant to those of us working at water utilities, where handling and using a variety of chemicals is almost a daily occurrence. The numbers are staggering. 43 million workers produce or handle 650,000 different chemicals on the job site. That is a lot of chemicals to keep track of, which is where a good hazard communication program comes in. OSHA's Hazard Communication Standard was developed in 1983 and based on a pretty simple premise, that employees have the right to know about the chemicals they are working with. The standard was revised in 2012. This video will look at the standard as it exists today, including its most recent modifications. Perhaps the biggest change was the adoption of the globally harmonized system of classification and labeling of chemicals, known as GHS. GHS is an international approach to hazard communication, providing agreed-upon criteria for the classification of chemical hazards. GHS also offers a standardized approach to chemical labels and safety data sheets. GHS is a United Nations document and was negotiated by hazard communication experts from many different countries, international organizations, and stakeholder groups. It's based on major existing systems around the world, including OSHA's Hazard Communication Standard. As a result of the adoption of the GHS, the Hazard Communication Standard of 2012 has several significant changes. For example, how chemical hazards are classified, the content and design of container labels, the content and format of safety data sheets, or SDS, formerly known as MSDS, and hazardous communication training to bring employees up to speed on these changes. The goal of adding the GHS to the standard is to enable employees to more quickly obtain and easily understand information about the hazards associated with the chemicals they are using. From a water utilities perspective, the overall goal of OSHA's Hazard Communication Standard has remained consistent since it was established: to make sure that employers and employees know all about chemical hazards, and thus can reduce job-related injuries and incidents that impact employees and the public. OSHA requires 5 distinct provisions in a utilities hazard communication program: hazard classification, labels and labeling, safety data sheets, employee information and training, and a written hazard communication program. Hazard classification begins with an inventory of all utility chemicals. The inventory includes all hazardous chemicals used at the water utility, those taken off-site for use in other locations, and even those stored outside of the main facility. OSHA defines hazardous chemicals as any chemical classified as a physical or health hazard, or which is a simple asphyxiant, combustible dust, pyrophoric gas, or hazard not otherwise classified. Consumer products defined by the Consumer Product Safety Act are exempt under the Hazard Communication Standard as long as they are used in the workplace as intended by the manufacturer, and that the exposure to the workers is the same as intended for consumers. In addition to surveying the entire facility, it's a good idea to refer to purchasing records to make sure you aren't overlooking any chemicals. And not just chemicals in containers. Chemicals in all physical forms, including liquids, solids, gases, vapors, fumes, and mists, are inventoried. Consider chemicals in containers, process pipes, and those generated in the workplace, such as welding fumes, dusts, and exhaust fumes. The chemical inventory list should reference chemicals using the name found on the container label and on the safety data sheet. In an emergency, employees and employers can look at the label and quickly locate the appropriate SDS. Every chemical inventoried is required to have an SDS. An inventory may help utilities better determine if a less hazardous chemical can be substituted or if a hazardous chemical that is no longer being used at the plant can be eliminated. Water utility employees have access to and the right to see the chemical inventory list. Employees can help keep the list current by notifying utility management if a new chemical is added to the worksite that is not on the list. Once the inventory is complete, all chemicals on the list will be evaluated and classified based on the defined GHS criteria. Chemicals are classified according to their health hazard based upon these GHS classifications: acute toxicity, skin corrosion or irritation, serious eye damage or eye irritation, respiratory or skin sensitization, germ cell mutagenicity, carcinogenicity, reproductive toxicity, specific target organ toxicity, and aspiration hazard. Chemicals that are health hazards can be either acute or chronic. Acute means causing an illness right away. Chronic means illness at a later date. Chemicals are also classified based on physical hazards, which refer to the chemical's physical properties, such as when it comes into contact with another substance. GHS physical hazards include explosive, flammable, oxidizer, self-reactive, pyrophoric, self-heating, organic peroxide, corrosive to metal, gas under pressure, and a chemical that emits flammable gas when contacted by water. Each hazard class can have up to 5 subcategories. For example, carcinogenicity has 2 subcategories. Category 1 is known or presumed human carcinogens. Category 2 is suspected human carcinogens. The GHS also classifies environmental hazards, but those classifications were not adopted into the Hazard Communication Standard since OSHA doesn't regulate environmental issues. However, employees may see environmental hazards listed on labels and in the SDS. Environmental hazards refer to a chemical's ability to harm the environment and are classified as an acute or short-term aquatic hazard, a long-term aquatic hazard, and a chemical hazardous to the ozone layer. GHS also has another category we need to be aware of, something called hazards not otherwise classified, or HNOC. These are chemicals that have evidence of adverse physical or health effects but don't meet the specific criteria of the GHS categories. The label and SDS must list these chemicals as HNOC. The next hazard communication standard provision that we will look at is labeling. All hazardous chemical labels must be legible in English and prominently displayed on the container, and they must have 6 required elements. Labels must have a product identifier, a name, address, and telephone number of the chemical manufacturer or importer, a pictogram, signal word, a hazard statement, and a precautionary statement. The product identifier is the name or number used on the label and SDS. It can be a chemical name, a product name, or other unique identifier that ties it directly to the SDS. The supplier identification is the name, address, and telephone number just mentioned. The pictogram is a symbol on a white background with red border that conveys information about the chemical hazard. A flame over a circle signifies oxidizers. A flame without the circle indicates flammables, self-reactives, pyrophorics, self-heating substances, substances emitting flammable gases, and organic peroxides. An exploding bomb pictogram indicates explosives, self-reactives, and organic peroxides. A gas cylinder indicates gases under pressure. Skull and crossbones signifies toxic or fatal substances. A silhouette body indicates health hazards such as carcinogens, respiratory sensitizers, reproductive toxins, organ toxins, and aspiration toxins. Corrosion symbols indicate corrosives and substances that are skin corrosives or can cause skin burns or can damage the eyes. An exclamation mark indicates irritants, skin sensitizers, acute toxins, narcotic effects, and respiratory tract irritants. This symbol is also used to identify substances hazardous to the ozone. As mentioned earlier, OSHA doesn't regulate environmental hazards. But if you see this pictogram, you'll know it's used to signify environmental toxins. Also found on labels is the signal word. It will either be danger for severe hazards or warning for less severe hazards. It will be accompanied with a hazard statement. These are phrases assigned to a specific hazard class and category such as fatal if swallowed and flammable liquid. Precautionary statements are also found on labels. There are 4 types of statements including prevention, response to spills or exposure, storage, and disposal. For example, wear protective gloves and use only with adequate ventilation. If chemicals at a water utility are transferred to another container, the new container should have the same labels and information of the original. The next OSHA hazardous communication standard provision is safety data sheets, formerly known as MSDS. Safety data sheets, or SDS, must be printed in English and be readily accessible in each work area where the chemical is used. The SDS sheets can be kept in a book as individual sheets or on a computer as long as workers can access them without leaving the work area. If kept on a computer, employers must provide a backup written copy in case of a loss of power. The location of the SDSs should be covered in the utility training program. These documents are the primary source and provide the greatest detail about each chemical to workers. The SDS will verify the information on the chemical label, help you determine what personal protective equipment or PPE is needed, and tell you if symptoms you may be experiencing might be caused by the chemical. Safety data sheets have a heading with an SDS number, an effective date, and a product identifier, a name or number that matches the chemical's container label. The SDS has 16 separate sections of important information. Section 1 includes the product and company identification with address and contact information. Section 1 also lists recommended use of the chemical and any restrictions. Section 2 is hazard identification. The required information includes hazard classification such as flammable liquid, a pictogram, signal word, hazard statement, precautionary statement, description of hazards not classified, and for mixtures, a percentage of the mixture that has unknown acute toxicity. Section 3 is composition and information of the ingredients. For substances, this includes chemical names, common names and synonyms, and any other unique identifiers. For mixtures, the concentration of all ingredients which are classified as health hazards are listed unless a trade secret mixture is claimed, which must then be noted. Section 4 is first aid measures. This includes a description of symptoms and recommendations for medical care. Section 5 is firefighting measures with appropriate extinguishing and protective equipment for firefighters listed, and hazards that may develop during a fire. Section 6 is accidental release measures with a suggested response to leaks, spills, and releases. Containment and cleanup recommendations are listed. This section also includes PPE and emergency procedures including evacuations if necessary. Section 7 is handling and storage. Here are recommendations for handling incompatible chemicals, general hygiene practices, and conditions for safe storage, including incompatibilities with other substances. Section 8 is exposure controls and personal protection. This section lists OSHA's permissible exposure limits, threshold limit values, and any other exposure limits set by the manufacturer. Engineering controls such as exhaust systems are listed, as are recommended PPE. Section 9 is a listing of physical and chemical properties. Included in this long and detailed section are items such as appearance, upper and lower flammability limits, odor, pH, melting and freezing point, evaporation rate, solubility, viscosity, vapor and relative density, and a number of other relevant properties. Section 10 is stability and reactivity. This is a description of specific test data for the chemical, an indication of whether the chemical is stable or unstable under ambient temperature and conditions, and required stabilizers needed to maintain conditions, and required stabilizers needed to maintain stability. This section lists possible hazardous reactions and a description of conditions that create reactions. Also listed are incompatible materials and possible hazardous decomposition issues due to use, storage, or heating. Section 11 is toxicological information. This section identifies toxicological and health effects, including likely routes of exposure such as inhalation, ingestion, or skin and eye contact. Also included is a description of the effects of short and long-term exposure and numerical measures of toxicity. Section 11 includes a description of symptoms from exposure, an indication of whether the chemical is listed in the National Toxicology Program and whether the chemical is a carcinogen. Section 12 is ecological information, providing detail on what the environmental impact of the chemical would be if released into the environment. This includes the potential for a substance to move from the soil to groundwater sources. Section 13 is disposal considerations, including a recommendation of disposal containers, methods, recycling possibilities, and special considerations impacting sewers, landfills, and incinerators. Section 14 is transport information for shipping and transporting of hazardous chemicals by rail, road, air, and sea. This section also lists precautions for transport within or outside of the immediate facility. Section 15 is regulatory information, identifying the safety, health, and environmental regulations for the chemical not listed anywhere else on the SDS, including national or regional regulatory guidelines. Section 16 is other information. This section provides the date of the creation of the SDS or revision details of the SDS. It's also a section used to provide any other useful information about the chemical. The fourth provision of OSHA's Hazardous Communication Standard is employee training and information. This ensures that anyone exposed to hazardous chemicals is provided information and trained prior to working with that chemical, and trained again whenever the hazard changes. The training can take place regarding individual chemicals or by grouping categories such as flammable chemicals. OSHA mandates that this be effective training. Effective is defined as a training program that provides employees with knowledge they need and that they carry that knowledge from the training into their daily duties and routines. Employers are required to make sure employees know the requirements of the standard where the hazardous chemicals are found in the workplace, where to find the chemical inventory and SDS, how to read and use the SDS, how to read the GHS container labels, and any other information relating to hazardous chemicals in the workplace. It's also required that the training is understood by the employees, even if it means providing an interpreter to explain the information in a language other than English. The final provision is the paperwork for everything we have just discussed. The formal written program that employers must create and maintain. The Hazardous Communication Plan will show how the utility has met all of the standards requirements. For example, how safety data sheets are received, kept, and are made available to employees. The specific names of the individuals responsible for the inventory, labeling, and SDS collection. How the hazardous chemical training is done, including first aid and emergency procedures, and dates of training deadlines. The written program contains a complete copy of the Water Utility Chemical Inventory. The written program explains how employees and their representatives are able to access the program documents. A good hazardous communication program reflects the efforts of everyone at the water utility, management, and employees. As with every other safety program, success depends on a commitment at every level of the water utility, not just the people who are responsible for administering the program. All of us as employees need to make this a part of our job.